Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET JEE-Main, we're going to be looking at previous year questions of chemistry asked in various entrance examinations in India. Today we're dealing with a very important topic. The topic is atoms, molecules, and chemical arithmetic. So this covers a very broad range of chapters in your syllabus in CBSE. This covers some basic concepts, atoms, and also a whole lot of stuff like calculation of molarity, number of moles, etc. So let's look at some questions which can be asked based on this topic, atoms, molecules, and chemical arithmetic. So here comes our first question asked in 2002. The question is the number of atoms found in 558.5 grams of iron at atomic weight of iron being 55.85 grams per mole is A, twice that in 60 gram carbon, B, 6.023 into 10 raised to 22, C, half that in 8 gram helium, D, 558.5 into 6.023 into 10 raised to 23. So which one of these options is correct? The first thing to do is to calculate the number of moles in 558.5 grams of iron. So basically the formula is number of moles equals given weight, given mass, divided by molar mass. In this case, the given mass is 558.5, molar mass is 55.85. You can see that they're the same quantity except that the numerator is multiplied by 10. So therefore the number of moles is equal to 10. So number of moles of iron is equal to 10, and so we need to find out which of these options would be the most appropriate. If you look at option D is 558.5 into 6.023 into 10 raised to 23. So that means it's equal to 558.5 moles, which is incorrect. If you look at option C, half that in 8 gram helium. So if you're checking out 8 gram helium, 8 gram helium has number of moles as 8 gram divided by 4 gram. That is equal to 2 moles, which is not the correct answer. Option B, 6.023 into 10 raised to 22, that will be equal to 0.1 mole. So therefore option B is also incorrect. The right option is option A, twice that in 60 gram carbon. So if you were to take 60 gram carbon and divide it by its molar mass, which is 12, 60 by 12 is equal to 5 moles, and the number of moles in iron is 10 moles. So therefore it is twice that of the number of atoms found in 60 grams of carbon. So option A is the correct option for this question asked in 2002. Let's move on to a different question. With increase in temperature, which of these quantities change? Is it A, molality, B, weight fraction of solute, C, fraction of solute present in water, D, mole fraction? Option D, mole fraction, refers to the number of moles of one element in a mixture divided by the total number of moles present. So if you say you have a solution, then mole fraction of solute will be number of moles of solute divided by total number of moles in the solution. So here there is no quantity that is dependent on temperature, so option D is incorrect. Option A, molality, is measured as the number of moles of solute divided by mass of the solvent in kg. Again, mass is a quantity that does not increase with respect to temperature, so therefore option A is incorrect. Option B, weight fraction, again refers to weight of A divided by weight of A plus weight of B. So weight of one component divided by total weight. Again, weight does not vary with temperature, so option B is incorrect. The right answer is option C, fraction of solute present in water. Now this quantity is dependent on volume, and when you have an increase in temperature, there will also be an increase in volume. So therefore, the fraction of the solute varies as well. So therefore, option C is the correct option. Next question. What volume of hydrogen gas at 273 degrees Kelvin and 1 atm pressure will be consumed in obtaining 21.6 grams of elemental boron, whose atomic mass is 10.8, from the reduction of boron trichloride by hydrogen? So we need to find out how much hydrogen is consumed in getting 21.6 grams of boron in a reaction. So the reaction is the reduction of boron trichloride by hydrogen. So if you were to check out the actual equation, the balanced equation is 2BCl3 plus 3H2 gives you 6HCl plus 2 boron. So three hydrogen gas molecules gives you 2 molecules of boron, 2 atoms of boron. So therefore, what you can do is divide everything by 2 so that the number of boron becomes 1. So the equation now becomes BCl3 plus 3 by 2 H2 gives 3 HCl plus boron. So as you can see in this updated equation, 3 by 2 times the volume of hydrogen, 3 by 2 times the volume of hydrogen gas gives the volume of boron. So gives a unit volume of boron. So using this relation, we can write that 1 mole boron, and remember the atomic mass is 10.8, so 10.8 grams of boron will be formed by the consumption of 3 by 2 times volume at 1 mole, that is 22.4 liters of hydrogen gas. So at 3 by 2 into 22.4 liters of hydrogen gas, 10.8 grams of boron is formed due to reduction of boron trichloride by hydrogen. Now, if you were to take 21.6 grams of boron, then basically on the other side you will have to consume 3 by 2 into 22.4 divided by 10.8 into 21.6 liters of hydrogen. So over here, if you take 108 and multiply that by 2, you'll get 216. So 21.6 is 2 times 10.8. So you get 2 in the numerator, and that 2 cancels with the 2 in the denominator, so you get 3 times 22.4 liters of hydrogen gas. So 224 times 3, 4 times 3 is 12, 2 3s are 6, plus 1 is 7, 2 3s are 6. So you get 21.6 grams of boron gives you 67.2 liters, is formed by consuming 67.2 liters of hydrogen gas. So therefore, among the 4 options, option B, 67.2 liters, is the correct option for this question asked in 2003. Let's look at this question. If we consider that 1 by 6 in place of 1 by 12 mass of carbon atom is taken to be the relative atomic mass unit, then the mass of 1 mole of a substance will it decrease twice or increase twofolds or remains unchanged or be a function of the molecular mass of the substance? So in the standard units of chemistry, the atomic mass unit is taken as 1 by 12 times the mass of carbon-12 atom. So that's the standard unit. Now what if we take 1 by 6 of carbon-12 atom instead of 1 by 12 as 1 atomic mass unit? So 1 AMU on scale of 1 by 6 of carbon-12 will be equal to 2 times 1 atomic mass unit on scale of 1 by 12 of carbon 12. Since, well, 1 by 12 is half as much as 1 by 6, so you have to multiply by 2 in order to get the same quantity. So for this case, you can see that the base unit has now changed, so therefore we would have to now find out the atomic mass of an element. So atomic mass of an element is usually written down as mass of one atom of the element divided by 1 atomic mass unit. And over here, since the scale is on 1 by 6, let's write it on scale of 1 by 6 of carbon 12 atoms mass. And since the denominator is equal to 2 times the original unit, so you can write mass of 1 atom of element divided by 2 times 1 AMU on the scale of 1 by 12 of carbon 12 atoms. So basically, the right-hand side now becomes 1 by 12, not 1 by 12, 1 by 2 times the atomic mass of element on the scale of 1 by 12 carbon 12 atoms. So basically, you are multiplying the atomic mass of an element by 1 by 2 in order to get the atomic mass of an element on the scale that 1 by 6 of carbon 12's mass is taken as 1 AMU. So therefore, if you were to check our options, option A, decrease twice, is the correct answer, because here the mass decreases by half, because the denominator increases. In any case, if the denominator increases, the numerator decreases by the same proportion. So here the denominator increases by 2, so therefore the numerator has to decrease by 2, so it decreases twice. This is the final question of this episode. How many moles of magnesium phosphate, Mg3PO4 twice, will contain 0.25 moles of oxygen atoms? So in these kinds of questions, it's important to find out how many oxygen atoms are present in one molecule. So in one molecule of Mg3PO4 twice, you will get 8 oxygen atoms, because in PO4 you have 4 oxygen atoms, and then PO4 is multiplied twice, so 4 times 2 is 8. So you have 8 atoms of oxygen present. And similarly, if you were to take that into moles, then you can write 8 moles of oxygen atoms are present in 1 mole of Mg3PO4 twice. Now, if we were to make the left side unity, that means 1 mole of oxygen atoms are present in 1 by 8 moles of Mg3PO4 twice. So when 1 mole of oxygen atoms are present, that means the amount of Mg3PO4 twice is 1 by 8. Now we need to calculate the amount of magnesium phosphate for 0.25 mole of oxygen atoms. So basically 0.25 moles of oxygen atoms are present in 1 by 8 into 0.25 moles of magnesium phosphate. So if you were to simplify this further, you can write 0.25 as 1 by 4, so 1 by 8 times 1 by 4, that gives you 1 by 32. So 0.0, then you have 3, 32 times 3 is 96, you get 4, that's 40, 1 times 32 is 32, so you get 8, that's 80, then you have 2 times 32, that's 64, you get 16, 16 becomes 160, 32 times 5 is 160, that gives you 0. So therefore 0.25 moles of oxygen atoms are present in 0.03125 moles of magnesium phosphate. This quantity can be written as 3.125 into 10 raised to minus 2 moles of. So if you were to, look at our options, you can see that option B will show you the correct answer. Using our calculations based on the amount of oxygen found in 1 molecule of magnesium phosphate, we can find out the amount of magnesium phosphate that's required to contain 0.25 moles of oxygen atoms. So that concludes this episode of NEET JEE Main preparation. We hope you found this interesting. For more useful and interesting content, don't forget to subscribe to our channel, that is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.